Hello, welcome to section 3.2. We're going to talk about standard form, which is one of our ways that we can write linear equations. So what we're going to do throughout this video is define variables, write equations in standard form. We're going to be able to solve the equations for one of the two variables, work through a couple more things talking about what are called intercepts, x-intercept and y-intercept. Y-intercept is the familiar one for you. And then we're going to be able to graph equations of lines from standard form using intercepts. So start off with this first example. High school soccer booster club sells tickets to the varsity matches for $4 for students, $8 for adults. So that happens in a lot of places. A lot of sporting events will charge less for students, more for the adults. They're hoping to earn $200 at each match. So there might be games where only students come. There could be games where only adults come. There might be a combination where there's more students and less adults, or vice versa. So there's a lot of combinations for ticket sales, but they want to earn $200 at each match. So write an equation to represent the amount that they would like to earn from the ticket sales at each match. So first thing I want to do is define my variables here. First thing, think about what their variables are. They're not changing the price for the number of tickets, but what the two variables are the number of tickets that they sell. So I'm going to let S be the number of student tickets. So it's not the price of the student tickets, it's the number of student tickets. And then I'm going to let A represent the number of adult tickets. Because the price is constant. It's $4 for students, $8 for adults. So there's a lot of different combinations. Here's how it's going to look in standard form. Standard form of an equation is AX plus BY equals C. A, B, and C are numbers. So A and B, since they're in front of variables, are going to be coefficients. And then C is going to be our constant number. So since X and Y are the variables, I'm using S and A. So what would go in front of my S value in this case? So how much is it for a student to go to the game? So that's going to technically be the A value here, the capital A. So it's 4S plus, I'm using capital B as to represent the price for adults, and instead of using Y as a variable, I use lowercase a. So 8A, and that would equal 200. So I know that it's $4 for a student, $8 for an adult, and I want the combination to be $200. And that's it. That's all we're doing is write an equation. Next one. Bakery sells bagels for 85 cents each, sells muffins for $1.10 each. They're hoping to sell $400 a day from both of these sales. So again, there's days when they're going to sell more of one than the other. One day they might sell only one and not the other. So let's define our variables. I'm going to let B be the number of bagels sold. So again, it's not the price, it's the number of bagels sold. And then I'm going to let M represent the number of muffins that they sell. Now I'm getting hungry. Okay, so when I write the equation, our coefficients are going to be these two prices, which are constant values. So 0.85 times the number of bagels they sell, plus 1.10, or you could just write it as 1.1, times the number of muffins they sell, and they want to reach $400. Next problems. So now we're going to be given the equation, and now we're going to be solving it to figure out how much of a certain quantity they need to sell to reach a goal. So the basketball booster club runs the concession stand. They sell hamburgers for $2.50 each. Hot dogs are cheaper; they're $1.50 each, and they hope to earn $900 during a tournament. So it's a lot of games, it's a lot of food being sold. Here's the equation. There's our two variables. First of all, are the number of hot dogs they're selling and the number of hamburgers. So they're letting B represent the number of burgers, and H is going to represent the number of hot dogs. So those are your two variables. Remember, it's not the price of them that's the variable, it's the number of each. So 2.50 times B, $2.50 for a burger, $1.50 for a hot dog, they want to reach $900. So it says if the booster club sells 350 hamburgers, how many hot dogs must they sell to reach their goal? So by giving you the hamburger amount, that's the B value. So what I'm going to do is substitute that in for the letter B. I'm going to put $315. and then 1.5. Now I cannot do anything for h. But notice my equation now only has one variable. So what we want to do is solve for that variable. So let's think about this. $2.50 for 350 hamburgers means that that business brought in $787.50 just in hamburgers. That is a lot of hamburgers. Okay, so we need to figure out how many hot dogs it takes because they want to reach $900. They already have $787. So how much more money do they need? Let's subtract that. So go to the calculator. I bring down my 1.5h. And in the calculator, I'm going to take 900 minus the 787.5, and I get $112.50. So they need $112.50 more to reach their goal, and they're selling the hot dogs for $1.50 a piece. So I'm going to divide both sides by 150, or 1.5, and I end up with 75. So in the very end, give a sentence answer. They must sell 75 hot dogs to reach $900. So to recap, we were given one quantity. We were given the number of hamburgers that were sold. So think about it. We have two variables in each of these problems where now I'm giving you one of the quantities and we had to solve for the other quantity. Next one, let's say they sold 420 hot dogs. How many hamburgers must they sell then? So I go back to the equation. This is different this time because I'm giving you the number of hot dogs. So 2.5 times the b value for the number of burgers plus $1.50 for all 420 of those hot dogs. And I want to know how much they're going to need to reach $900. So 2.5b plus, I'm going to take 420 times 1.5, and I get 630, and then I want to bring down the equals 900. So what this means, again, they earned $630 so far. They're trying to get to 900. So let's see, how much money am I going to need if I take away the 630? 2.5b equals $270 more to reach their goal. So if they're selling hamburgers for $2.50 a piece and they want to reach $270, how many are they going to need to sell? And divide it, you're going to end up with 108. So sentence answer, they need to sell 108 burgers to reach $900. Okay, so this is assuming that they're selling a combination of both. They're selling some hot dogs, some hamburgers. Some days you'll sell more of one than the other. The next problems are a little different because now it's saying, what if they sold 0 hot dogs? Well, how many of the other one must they sell to reach their goal? And then the bottom one is saying, let's sell 0 hamburgers. How many of the other quantity must they sell to reach their goal? So I want to brainstorm this first. If the hot dogs are cheaper, are they going to need to sell more or less to reach a goal? So imagine, they're selling something a lot cheaper than the hamburgers are, so it's going to take them a lot more hot dogs to reach their goal. So that number is going to be greater, and then the other one will be less than. So let's kind of just substitute these values in just like we did before. We're assuming 0 hot dogs, so 2.5 times b plus 1.5 times 0. We're assuming they're bringing in $0 from the hot dog, so that means that's going to go away. And you're left with 2.5b equals 900. So what you need to do is divide 900 by 2.5, and that means that they are going to need to sell 360 hamburgers to reach their goal, which is going to be different than the next one because that's going to say we're selling 0 hamburgers. So substitute 0 in for b, and I'm going to keep this as 1.5 times h. Now, how many hot dogs would it be? So they're bringing in $0 from the hamburgers. So I'm going to divide both sides by 1.5 because I want to sell $900 worth of just hot dogs. That's a lot of hot dogs. And that comes out to 600. So notice from the beginning of this problem, since hot dogs were cheaper, I said that they would need to sell more of them. So notice they'll need to sell 600 hot dogs to reach their goal, versus if they sold 360 hamburgers, they would reach their goal. And now we get into these ones. So we're going to sell some really different types of numbers here. We're going to probably end up with some decimals and need to do some rounding. So for these, if they sell 281 hamburgers, how many hot dogs must they sell? So 2.5 times the 281 hamburgers plus 1.5 times whatever number of hot dogs. We want to reach 900. So we're going to go about this the same way. 2.5 times 281 means that they took in $702.50. And they're trying to reach that goal of 900. So I'm going to take 900 minus the 702.5, and that means that they need to come up with $197.50 more cents from just hot dog sales. So when I divide by 1.5, and I encourage you to try this on a calculator, what you end up with is H equals 131.67. Let's think about that. I've never gone to a concession stand and said, give me 0.67 of a hot dog. You can't buy 2/3 of a hot dog. I can either buy a whole hot dog or I can buy no hot dogs. I could buy 131 hot dogs. I could buy 132 hot dogs, but I cannot buy 0.67. So I want to think about this. I took in the concession stand took in $702.50 from just hamburgers. Now, I want you to think, what if I rounded down? What if I sold $1.50 for every hot dog and I sold 131 of them? That would come out to $196.50. So if I add these two together, I end up with 702.5. You end up with $899. There's a problem with that. What are they trying to reach? They're trying to reach $900. So I cannot round this down. So what that means is they need to sell 132, I need to round up, 132 hot dogs to reach their goal. So if I round down, they don't make enough money. So what that means is in order to reach a goal, I need to round up. And that's probably what we're going to do with this bottom one then too. Again, you can pause the video, try it yourself, and then keep going. It's going to flip-flop it again where I'm giving you the H value. So 2.5 times B plus 1.5 times 168, and that's going to equal 900. So I want to know how many hamburgers are they going to need to sell. So if they sold 168 hot dogs, that brought in $252. So they have a lot to go. So how much more money do they need to save? Let's subtract 252 on both sides and find out. So I end up with 2.5b equals 900 minus 252, which is $648 more. So if I need $648 more and I'm selling the hamburgers for $2.50 a piece, let's divide both sides by 2.5, and again, I get a decimal. I get that b equals 259.2. So I cannot sell 0.2 hamburgers. That would be like a tiny little bite. You can't sell 0.2 of a hamburger. You can either sell 259, but that wouldn't be enough money, or 260. So they need to sell, and let's round up, 260 burgers to reach their goal. And then we would have enough money. We would reach $900. Again, you could substitute that back in. If I took 2.5 times 260, and then I added the money that I had from the hot dogs, I would end up with $902. And that would be over my goal of 900. So we reached the goal, but only if we rounded up there. Now we're going to go on to some more just algebra, where what we're going to do is calculate intercepts, x-intercept and y-intercept of equations. And what that means, if you think about it, when we solve for y-intercept, that was when our x value was 0. When we solve for an x-intercept, our y value is going to be 0. So on a coordinate plane, I'll draw a grid on here. If you think of any point, let's say I drew a point up here. I said that this point was 0, 3. And then let's say I went over here. This point would be 2, 0. So if I drew a line, let's pretend I drew a line between these 2 points. My first point up here, this is where the function crosses the y-axis. Where it crosses the y-axis, notice your x value is 0, and you get a y value. where it crosses the x-axis, your y value is 0. So how we're going to solve for intercepts, if I want to find the y-intercept, I'm going to have to substitute 0 in for x. So I'm going to do 20 times 0 plus 8y equals 240. So this is just like when we did the little burger and hot dog thing, and I said suppose I sold 0 of one and I sold a bunch of the other one to reach a goal. Just like that. This first quantity is going to drop out. I'm going to have 8y equals 240. So that means y is going to end up being 30. So that y-intercept is the point 0, 30. In order to find the x-intercept, I'm going to just substitute 0 in for y. 20x plus 8 times 0 equals 240. Like I said, this part's going to drop out because anything times 0 is 0. So you get 20x equals 240. And that's going to end up being, when you take 240 divided by 20, you're going to end up with 12. So that coordinate would be the point 12, 0. So this is your y-intercept because I have a value for y. This one's your x-intercept because notice my value is put in for x. The next one, so that was from standard form. The next one is going to be what if it's in slope-intercept form. So we're going to do this the same exact way. I'll show you that if we want to find the y-intercept, what I'm going to do is substitute 0 in for x. And notice the y-intercept is the b value. It's in y equals mx plus b form. Well, yeah, y is going to end up being 52 because your x quantity goes away. So that coordinate is 0, 52. If you want to find the x-intercept, I need to substitute 0 in for y. So I get 0 equals negative 4x plus 52. And I need to solve this equation. So what I'm going to do is add 4x to both sides to bring this over. And I end up with 4x equals 52. And what you want to do is divide both sides by 4. So I get x equals 13. So that intercept is the point 13, 0. Again, to find the x-intercept then, we just substituted 0 in for y. So the point of using intercepts is that you're able to graph an equation using them. So that's what I'm going to do in this. In this problem, we're going to determine what the intercepts are, and then just basically plot 2 points on a line and connect the dots. So what I want to do is find the y-intercept first. It doesn't matter which one you do find first. So to find the y-intercept, what I'm going to do is substitute 0 for x. So 12 times 0 minus 9y equals 36. So if negative 9y equals 36, that means my y-intercept is going to be negative 4. So I get a point. My y-intercept is the coordinate 0, negative 4. In order to find the x-intercept, what you're doing is substituting 0 in for y. So 12 times x minus 9 times 0 equals 36. Goes away. 12x equals 36, which means my x-intercept is going to be at 3. So that's the coordinate 3, 0. And again, this is always x, y, and since we substituted 0 for y, we got our x-coordinate of 3. Over here, I substituted 0 in for x, and I got my y-coordinate. So all that you have to do is plot both of these points and then connect the dots. So 0, negative 4 means it crosses the y-axis down 4. 3, 0 means I'm crossing my x-axis over 3. And then what we're going to do is just connect the dots on these 2 points, and that's our line. So that's how you graph a line using intercepts. Here's one more of those. Notice this is in slope-intercept form. So I'm going to solve this same way. Let's find our intercepts. I know that in order to find my y-intercept, I'm going to substitute 0 in for x. And my y-intercept is the point 0, negative 15 then. So 0 for x, I get negative 15 for y. And then to find my x-intercept, I'm going to substitute 0 in for y. So in order to solve this equation, what I'm going to do is add 15 to both sides. And I get 15 equals 3x. So then divide both sides by 3. 15 divided by 3 means that my x value is 5. So if x is 5 and y is 0, that's my x-intercept. and then this point over here is my y-intercept. Slight problem. This graph only goes 10 in each direction, and I need to graph 15. So what I'm going to do is count by 2's. 2, 4, and again, that's negative for the y-intercept, so 2, 4, 6, 8, 10, 12, 14, and 16. So between 14 and 16 is down here. So here's my y-intercept of negative 15, and then make sure you're counting by 2's over here. 2, 4, and 5 would be between 4 and 6. So there's my 2 points. Once you have your 2 points, I'm going to connect the dots by just drawing a straight line through them. That was ugly, so let's move the bottom part down. Bam. Okay, so I got my line. Again, we graphed our line by using our intercept. So just to make a recap, from the top, what we did is we talked about what standard form was. We set up equations in standard form by defining two variables in the form of ax plus by equals c. We solved our equations to figure out how many of another variable you would need to reach a goal. We figured out what happens when we solve for substituting 0 in for them, which we found out later was solving for intercepts. We talked about what rounding would look like if we came out with some ugly numbers, how we would have to round up to reach a goal. We solved for what our intercepts were, and then we graphed equations of lines using intercepts.